Thank you for the nice introduction. I will speak about a computer game that I have developed in order to help teach natural deduction for propositional logic to first-year students. Before going into the game, I want to give you a little bit of background about my university. We are organized into so-called faculties, what you would typically call a department in other places. And at the Faculty of Computer Science, we have students at all levels, bachelor students, master students, and PhD students. Most of them are bachelor students, so we enroll about a little bit more than 300 students each year. And we have two study programs, computer science in Romanian and computer science in English. And this year we are tentatively starting a new study program on artificial intelligence. We also have master students who are a little bit less, and we also enroll PhD students. But most of the activity focuses on the bachelor studies. And together with a few colleagues, I am teaching this mandatory class called Logic in Computer Science. It is for first-year students, and essentially everyone has to take it. There are many kinds of students that we have, but I'd say that the typical student profile is that they already know to some degree how to program, because most of our students learn some sort of C++ in high school. And they also have the typical knowledge that you would expect for high school level mathematics. And we also have, for most students, an admission contest where they have to do either math or computer science. So this is the sort of students that I get in the lecture. And for the lecture, there are two parts. In the first half of the semester, we teach propositional logic. And the topics that we cover are informal logic, and then immediately after we move on to symbolic logic, we cover formal syntax, formal semantics, which is something new for the students, and natural deduction and resolution as proof methods. And then essentially all of these topics we do again for first-order logic. In this talk, I want to discuss a little bit about the difficulties students have when getting to natural deduction. So up to that point, the lecture seems to be easy, but natural deduction is a pain point for most of our students. They find it difficult. So without getting into too many technicalities, let me tell you what natural deduction is, just so that we are on the same level here. So there are two things to learn. There are the inference rules, and there are formal proofs. The inference rules, they describe what the logical connectives mean. And I have chosen here some simple rules for the conjunction connective, which we write as this wedge. And there are typically introduction rules and elimination rules. Introduction rules is how can you prove a conjunction? And you have to prove both conjuncts. If you manage to prove phi and then you manage to prove psi, the rule allows you to prove phi and psi, a single conjunction. And the elimination rules for conjunction allow you to prove either conjunct. Once the students know the inference rules, they must understand what a formal proof is. And the formal proof is just a sequencing of these rules so that you get from the hypothesis to your desired conclusion. And I have here an example where my hypothesis is that I know a conjunction P and Q, everything and R, and I want to prove as a result line 5, Q and R. And the way I need to do this is to apply the proof rules line by line, step by step get to the result. So for example, here on the second line, I am applying one of the rules for eliminating conjunction, which tells us that we can keep the left-hand side. So we have this on line 1, the main connective is a conjunction. We keep the left-hand side, which is P and Q, and so on and so forth until we massage the proof into the conclusion we want. Okay, this gets a little bit scary for the students. And the way we teach it is a little bit like you would do math. And the students have to do formal proofs. And I have here 2 proofs that I have extracted out of an exam I gave a few years ago. The writing is mine, but the proofs were done by the students. And there is a wrong proof on the left-hand side and a good proof on the right-hand side. And the left-hand side is it is really bad because I can see here that the student completely failed to understand the point in formal proofs. So for example, when the student went from line 2 into line 3, he used a so-called rule for negation elimination, which we can see on the right part of the sheet of paper. And the student thinks that negation elimination is simply remove the negation connective. But this is not what the inference rule does. And on the right-hand side, we have a good proof, which is a little bit more involved. And I can see here that the student has understood how negation can be handled. But unless you are an expert in this field, if I gave you these 2 sheets of papers, you couldn't tell them apart. And I think most students who do not understand the topic cannot tell these apart, and they cannot know when they are wrong or right. So this is the difficulty of doing such proofs. Okay, and a few years ago, I had this idea of developing a computer game, which is called LND, for Logic Natural Deduction, which is a game that allows you to make computer-assisted proofs of such formulae. And this is a screenshot of the game, but I'll show you the game in real life if I need to exit the presentation and bring in a web browser. So now you should see the game. The game is organized into levels by increasing order of difficulty. And well, there are a few rough edges regarding the graphics, but here in yellow, you have the hypotheses that you are starting from, and in this dark red, you have the conclusion that you need to reach. And down here, there are all the proof rules that you can use. And the game allows you to develop the formal proof backwards, that is starting from the conclusion towards the hypothesis. And all you have to do is click the proof rules. What proof rule are you trying to use? In my case, I'm trying to prove a conjunction. So I want to use the introduction rule for conjunction, which is this one highlighted here. Okay, once I click the rule, I have 2 new things to prove. I have to prove Q, and then I have to prove R, focusing currently on Q. How do I prove Q? I need to extract it from this conjunction here, and I cannot click the conjunction directly. I have to say that I need to use the second rule for eliminating conjunction, which is this one highlighted here. Okay, and the system tells me that, okay, you want to prove Q using this rule. So you need to be able to prove placeholder, (5) and Q. And you can put in anything you like on (5). And my hypothesis here matches what I want there. So I click the hypothesis and the placeholder is filled in. Okay. The next thing that the next proof obligation that remained was this R here, which is one of the hypotheses, and now I can conclude. Now I have a formal proof, and I can go to the next level, which is very similar. I'll just very quickly solve it, but you can have a little some levels that are a little bit more complicated. So here there are a few negations involved. So I would still use the rule for introducing the conjunction operator, and then here I have to prove a double negation. I guess I can use this rule for proving double negation, and then I can click the hypothesis, and so on and so forth until I solve this level as well. One thing that I want to mention is that the game is designed in such a way that you cannot end up with an invalid proof. So if you try to do something that doesn't work, the game will not allow it. It will say you cannot apply this rule. And unless there is a bug in the way I have programmed the game, if a level is finished, then surely the student has solved that proof correctly. Moving on to the conclusion, I was initially very excited to use this in the class, but I have noticed that not all students enjoy it. I'd say that a minority of students were very excited to use the game, and they told me, yay, I have finished all levels, very interesting, they liked it, they enjoyed it, they learned something. But a majority of the students were not engaging with it. And I currently do not have a hypothesis why that is. Perhaps they like pen and paper more. Perhaps they just don't like games, interactive games. And what I do is that I tell the students about the game, but it is not mandatory to use it. So I leave it as an elective, and some of the students, I think, get a benefit of by playing this game. And I guess I can stop here. And if you have any questions or feedback, I would be happy to take it. Thank you very much.